Hey everyone, welcome back. In this lesson, we're going to examine the results from the last couple of lessons. So, 2 videos ago, we graphed a couple of lines where we changed the value that we were adding on to x in our equation. So, 2 videos ago, don't write this down. Just flip open your notes to the appropriate page. I believe we graphed something like y equals x plus 2 and y equals x plus 1. That looks like a slash. Y equals x plus 2 and y equals x plus 1. That was 2 videos ago, and when we tried to plot those, we ended up getting 2 lines that looked something like this. So the lines had the same angle, they were sloped the same amount. They did not pass through the origin, but they passed through the y-axis at 2 different points. And what we're going to pay attention to today is what those points are, how we can figure that stuff out without needing the table of x and y values that we've been making so far. And we're going to see how changing this number changes the lines when you actually graph them. And then in the last video, we graphed 3 lines. We graphed y equals 2x, y equals x, and y equals x over 2, or 1/2 x. And when we tried to plot those, can you see all of that? I think you can see all of that. I'm going to back up just a smidge so you can see the whole board. And then when we tried to graph those, we ended up with something like, so we had y equals x that looked something like this, y equals x over 2 that looked something like that, and y equals 2x, which looks something like that. So what we can see here is that when you change this number that's being added on or subtracted, addition or subtraction here is fine. When you change that number, what ends up happening is you're physically moving the line up or down, right? Up if you're adding to x, and down if you're subtracting. And down here, what we can see is that when you change what you're multiplying x by, here it's sort of like there's an invisible 1 in front, so it's like y equals 1x is the same thing as y equals x, and this one is 1/2 x. So when you change the thing that you're multiplying x by, that changes the angle of the line, the slope of that line. So like if it was a mountain, you could describe it as a steeper hill, a steeper slope, and then some shallower ones going that way. So we're going to put those 2 ideas together, and we're going to create an equation for a line. So basically there are 2 different things that we can do. One is that we can multiply x by something, and it could be multiplication or division. If it's division, then you could always write it as a fraction multiplied by x, right? This is the same thing as x divided by 2. That's the same thing as 1/2 times x. So you can multiply x by something, or you can add something on to x, right? Or subtract. I could have said x plus -2. That's the same thing as x minus 2. So adding and subtracting go hand in hand, multiplying and dividing go hand in hand. So what we get is that if you add on something, that's going to change how your graph looks. And if you multiply x by something, or if you multiply x by a few different values, that'll change the graph in a different way. So what we're going to do is we're going to combine those ideas, and then we're going to graph some lines to really drive that point home. So, what we've got now is, I'll give you an example of a line, and we're going to identify each sort of component of the equation that's of importance to us. So we know that in every equation of a line, we're going to have a y and we're going to have an x, because those are the actual values of the points that are going to be in there. So we're going to have a y, we're going to have an x, leave a gap here. And what we know is that we could multiply x by some number to change the way the line looks, and we could add or subtract something to change how the graph looks as well, right? If we change this one, this is going to change the angle. So this one affects the angle. So affects the angle of the line, and this one is moves the line vertically. So vertically is up or down. So it could move the line up if it's a positive number, could move the line down if it's a negative number. And the number that goes out here, we've only so far explored whole numbers and fractions that are all positive. So we tried it with 2, we tried it with 1, we tried it with 1/2 going over here. But it also works for negative numbers. You could even have a 0 there, but 0 is a little bit boring. So we're going to ignore that for now. So yeah, you can have positive or negative numbers or 0 here. You can have positive, negative, or 0 there as well. You can have fractions, you can have decimals, you can have whatever you want going into either of these two boxes. They don't have to be the same number. They can be. They could both be 0, but that's even more boring. You could have them both be really weird numbers. You could have like pi times x plus pi if you really wanted to. So yeah, there's lots that you can do with those, but what we know is that there's going to be at least one number here and one number there. If we're just graphing y equals x, if we were just graphing y equals x, I think we can agree that that's the same thing as graphing y equals 1x plus 0, right? So even though y equals x looks a lot simpler than whatever we've got going on up here, we still have each of those components. We still have something that x is multiplied by, it just doesn't happen to change it, and we still have something that's added on, we just don't happen to change it. So what this allows us to do is this allows us to develop an equation of a line. And we know that we can see even in those simple cases that there's still a number here and there's still a number there, and we can just choose a couple of special values. If we don't want to move the line vertically, we put a 0 here. If we don't want to change the angle of that line, we put a 1 here. So that's it. There's just a couple of special values that don't affect the line at all, but other than that, any number you put in there is totally valid. So I'm going to erase this. I'm going to end up basically rewriting this, but what I'm going to do is I'm going to replace the boxes with different placeholders. So right now I just put 2 boxes there to sort of indicate that there's a number that's supposed to go there. But I'm going to replace those boxes with letters. So we've got equation of a line. Smiley face. Sweet. All right, so the equation of a line. So what we just wrote down was y is equal to something times x plus something, right? But I'm going to replace those boxes and write this in a slightly more proper way. For those of you that remember the videos we did last year on linear functions, you might recognize this now. The equation of a line is y equals mx plus b. All right, this right here is the equation of a line. And there are a couple of other ways that you could write it. You could put you could put the x's and y's both on one side and sort of rearrange things. There's different ways that you could write out an equation like this, but this is the form that we're going to be working with. So we're going to always write it out this way, and we're going to be graphing our lines using equations that look pretty much like this. So let's just break down what each of these things are. The x and y, we don't actually touch those. The x value we choose, and once you know the numbers for m and b, those are just the numbers that are going in here, right? Those are numbers that will be given to you. Once you have m and b, you can find what the y value is. So that's the whole point, is that your machine, when you put in an x value of your choice, so you put your x value that you've chosen in here, it's gonna multiply, let me see if I can, yeah, I can write the whole thing in here. Multiply by m, right? It's going to be x times m. So it's multiply by m and add b, whatever that number happens to be. And then it'll spit out y based on that. So it'll take the number that you put into this. So you choose this x value, right? I'm going to get rid of the one with boxes now because I need some space. You choose this value right here. So you get to choose this. And then you put that into your fancy function making machine, and it's going to multiply it by some other number, m, And then it's going to, once you've done that multiplication, it's going to add on some number b. So in a question, I would give you the number for m and the number for b. So I would give you something like, don't write this equation down, at least not yet. I would give you something like y equals 2x minus 2. So this one is in place of m, and this one is in place of b. Remember the minus sign. This is the same thing as 2x plus negative 2. Right? So you can see that this right here is that first placeholder is replaced with this 2, and that second placeholder is replaced with that negative 2. So this m and this b are just placeholders for us right now. And we give them names, and I'm gonna explain the names. We'll see what they do when we try graphing a line. So m, this one right here, is called the slope. So if you remember, the first placeholder, the one when you're multiplying x by something, that changes the angle, right? That changes the angle of your line on the graph. So it could make it steeper, it could make it shallower, it could make it perfectly flat or perfectly vertical. That all depends on this m value right here. So whatever number I give you there is going to give you some idea of the direction that that line is pointing in. If it's 1, your graph is going to look like this. If it's 0, your graph is flat. If it's negative 1, it's going to look like that. So all of that stuff with the angle of the line is due to this m right here. So we call it the slope because it's sort of giving you that steepness of the line. This one over here has a bit of a strange name. It's called the y-intercept. It's called the y-intercept. Now, you might not have noticed this when we were actually graphing lines where we were adding on a term, like when we did x plus 2 and x plus 1. You might not have noticed this when we were doing that, but if you notice, if you look back now, you might notice that when you're graphing y equals x plus 1, the line crosses the vertical axis, the y-axis, at the point 0, 1. So at a value of 1 on the y-axis. So let me explain that with a little bit of a picture. I'm going to get rid of this function down here. I don't know if it was helpful to you guys to have that sort of picture of the function machine doing its thing. So if you've got your axes like this, right, and you've got 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, x and y, then if you're graphing y equals x plus 1 on this thing here, what you're going to end up getting is something that looks like this. You're going to get a line that looks like that. And so this line crosses the y-axis at the point 1, right? At the point, well, this point right here is technically the point 0, comma 1, 0 on the x, is like 0 in the x direction, 1 in the y direction, but really the only thing you have to pay attention to is that this number here is the same as this number here, where the line crosses the y-axis. So that's what this b value is telling us. If we were graphing y equals x plus 2 instead, it's going to cross at 2. And you don't have to take my word for that. You can construct the table that that we've been using for the past couple of classes, and you'll see for yourself that if you're trying to graph y equals x plus 2, as long as you do it right, your line should cross at a value of 2. All right, so that's why it's called the y-intercept. We're going to explore this in a little bit more detail by graphing one line that has all the bells and whistles, that has a slope and it has a y-intercept, and we're going to have to worry about all of that stuff. And it's actually going to be the equation I wrote down a couple minutes ago. We're going to try and graph that. So just make sure you have this equation written down, and then I'm going to erase this. We're going to draw a Cartesian plane, but it's going to look slightly different, so wait for me to start drawing mine so that you can see how it's different, and then you can draw yours accordingly. So the equation that we're going to be graphing is y equals 2x minus 2. All right, so I'm going to put that equation there. Hopefully you've got this copied out by now. So I'm going to get rid of that. Although I guess you guys have the advantage of pausing and rewinding as well if you really need to. So this is the equation that we're going to try to graph, but here's how our graph is going to look. We're going to have our y-axis be kind of really big and our x-axis cut through the middle. So up until now, we've only sort of used this much of the graph. I'm asking you to just make the y-axis a little bit longer down below, so that we have some more values that we can put down here. So something like this, 1, 2, 3, 4, 5. And the rest of it's going to be the same. We're still going to be counting by ones on the axis. This is still the x1, that's still the y1. No problems there. And there's our equation. So we've got our 0 here. We'll label these 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then going down below 0 is going to be negative 1, negative 2, negative 3, negative 4, negative 5. Don't draw what I'm about to draw. I'll draw it in blue just so that you can see that there's a difference. But this Cartesian plane does extend to the left as well. So if I really wanted to, I could have made my Cartesian plane go out this way and then put negative 1, negative 2, negative 3, and so on in the x direction as well. So then we have something like a big plus instead of just like this L shape that we've got going over here. We'd have this big plus, and you could draw a line anywhere in this space. So ultimately, that's what we're going to end up working towards. But right now, we're just getting up there, starting from just the first just positive x and positive y. Now we're dealing with positive x values, but y could be anything. And then we'll eventually include some negative x values as well. So going up in baby steps. Not that you guys need baby steps. Most of you have seen this before. All right, so once your graph looks something like that, I'm going to tell you a couple of tricks. Now, we could go through and plot a few points. Maybe we should go through it that way. Yeah, we'll go through and plot a few points just using the table, the good old-fashioned table, but I'm going to speed it up ever so slightly, just so that I can show you a couple of neat shortcuts. So, let's say I choose the x values 0, 1, 2, 3, no problems. We'll keep it simple. So we choose the x values 0, 1, 2, and 3. So for x equal to 0, that's going to tell us that y is equal to 2 times 0, we plug in that 0 there, minus 2, right? I'm sorry I can't make this any bigger, I should have moved the table down and stuff, but I'm going to try and squeeze all 4 in here. So if we get y is equal to 2 times 0 minus 2, that's going to be equal to negative 2, right? Because 2 times 0 is 0, minus 2 is negative 2. So when y is equal to, when x is equal to 0, y is equal to negative 2. When x is equal to 1, y is equal to 2 times 1 minus 2. 2 times 1 is 2, minus 2 is 0. So when x is equal to 1, y is equal to 0. Great. When x is equal to 2, y is equal to 2 times 2 minus 2, which is equal to 2 times 2 is 4, minus 2 is 2. So when x is equal to 2, y is equal to 2. That's nice. We have a lot of 2's in this line. 2 times 2 minus 2 is equal to 2. Great. And then the last one, when x is equal to 3, we get y is equal to 2 times 3 minus 2. And 2 times 3 is 6, minus 2 is 4. Again, if you started to see a bit of a pattern, then you don't have to go through that calculation every time. If you can see that it's going, oh, okay, as x goes up by 1, y goes up by 2, then you can just go with that and you can start filling out your table with more and more points. I could just extend this table down and do x is equal to 4, y is equal to 6 without even calculating, because I'm just noticing the pattern between the two. Now, let's try and plot this. We won't necessarily worry about that last point because that was a bit of an afterthought, but we'll plot these first 4 up to here. We'll plot those first 4. So, if we look at our Cartesian plane, when x is equal to 0, so that's without moving left or right on the x-axis, y is equal to -2. So instead of moving up, we're going to move down to -2 right here. We're moving down because the number is negative. If it was positive, we would still be moving up. All right, when x is equal to 1, y is equal to 0. So when x is equal to 1, we move 1 over this way. Y is equal to 0, so we don't move up or down at all. We put our dot right there. Okay, when x is equal to 2, y is also equal to 2. So we go 2 units to the right, so that's over here, and then we go 2 units up, so to about there. Hoping that's lined up. That looks roughly lined up. All right, I should have drawn some grid lines, but that's all right. When x is equal to 3, y is equal to 4. So when x is equal to 3, that means I'm moving over 1, 2, 3 to right here. And then I have to move up 4 units, so up to about there. Something like that. That's a little bit too far over. Can I bring that over here? Is that better? Have I done this right now? Something like that. Yeah, all right, so just in case it's a little bit hard to see, for the ones that aren't sitting on one of the two axes, that's when x is equal to 2 and y is equal to 2, the dot's lined up with that. And when x is equal to 3, y is equal to 4. So that's how they're lined up there. And we could do 4 and 6 if I just had a 6 right here. Since it's only just off, I could sort of like throw in a 6 and then we could try and plot it. But without having the grid lines and stuff, it's just not worth it right now. And we've got enough dots that I think we can connect them now quite safely. So if I try and connect these dots, I'm going to get something like this. And if I go in the other direction, same idea. And we get a line that looks something like that. Great. Okay, so there's the equation, or there's the graph of this line, y equals 2x minus 2. Now, here I'm going to give you guys a little bit of a shortcut. So this is the graph for y equals 2x minus 2. This is a totally valid way of getting to that result, but I'm going to show you a little bit of a shortcut. So I'm going to start with the easier part of the shortcut. I'm going to write in the equation of a line that we had from before, so with the placeholders in there. So we had y is equal to mx plus b. Right? Now m is the slope, and b is the y-intercept. Just barely squeezing that in. So b is equal to b is called the y-intercept, and m is the slope. So over here, what we can see is this one right here has taken the place of that m over there. Right? This first 2 is our slope. And this -2 in here, I have to include the negative because the equation doesn't have the negative already there for me, which means I have to account for it over here. So this whole -2 in there is my y-intercept in this equation. Right? That makes sense, hopefully, based on that equation. We're just looking at the two equations and comparing where the things are. So this 2 is the thing that's being multiplied to the x. We know the thing that's multiplied with x is the slope, therefore this 2 is the slope, and then the thing that's being added or subtracted is going to be our y-intercept. That's the same thing that we have over there. So this tells us that our slope is equal to +2, and our y-intercept is equal to -2. -2, remember, again, because we don't have the minus sign in the equation, this thing is basically the same as 2x plus -2. And so that's why the -2, the negative has to stay with the 2 in your y-intercept. So these are two very useful pieces of information. And if you can find these two pieces of information for any line, you don't need that table of values of choosing an x value and plugging them in one at a time to get a y value and then plot those dots individually. If you can get these two pieces of information, which we just looked at the equation and just picked them right off, right? We just looked at the equation and said, oh, there's our slope, There's our intercept, all done. If you can get these two pieces of information from your equation, you can graph the line in about 15 seconds. So, what does this tell us? Well, the y-intercept, if you remember from what we were doing just a few minutes ago, we said that this number for the y-intercept, this number up here, is the same as where the graph crosses, or where the line crosses the y-axis on the graph, which you can see is true, right? Where the y-intercept is -2 in our equation, our line crosses the y-axis, that's the vertical axis, crosses the vertical axis right here at -2. So that tells us that no matter what the angle of the line is, as long as we have this -2 sticking out at the end, there's going to be a dot at -2 on the vertical axis, on the y-axis. Okay, so you can just go ahead and drop that point right there without having to do any sort of multiplication of, 2 times 0 minus 2 is equal to -2, like we just did before. As soon as you can see that there's this -2 sticking out on the end by itself, drop a dot at -2 on the y-axis. Now, going from here, it's a little bit trickier. So there's a little formula that you should remember, and you should definitely write this down because this is gonna be a big help to you when you're working on like practice questions and stuff for this. So slope is equal to rise over run. This is extremely important if you want to use the shortcut. You need to remember this if you want to use the shortcut. So, what does this mean? Rise over run. What it means by rise is how much you... So if you're starting at a point like this point over here, the rise is how much you have to move up in order to get to the same level of the next point. So like from here to here, from this point to that point, the rise is this distance right here. Okay? And the run is how far over you have to go to get to the next point. So this is easier to see once you've already graphed it, but you can use this formula to plot new points on the graph without needing to use any old points. All you need is one starting point, and then you can build the rest of the line using this equation. So if you look at going from this point to this point, our rise is strictly in the vertical direction. It's only moving up, and then the run is only moving to the right, and it's always up and to the right. If you have a negative sign, then it'll flip. So either you'll be going down and to the right or up and to the left. We're going to get into that later. Don't worry about that right now. We'll talk about negative slopes next class probably, or maybe the one after that, but we'll see. It'll be coming soon, stuff with negative slopes. But so this right here is our rise. Hopefully you can see that and read that. Trying not to scrunch it too much, but so there's our rise and our run. So our rise is how much we have to move up from one point to the next one, and our run is how much we have to move over to the right to get from one point to the next one. Now, this by itself isn't necessarily helpful, but what we do know is that our slope in this particular example is 2. So we know, I'm gonna have to, what can I do? Maybe I'll move the equation over there. So we've got y is equal to 2x minus 2. I'm gonna get rid of this because I need a little bit of space. So what we know is that our slope is equal to rise over run, but we know that that's equal to 2 for this particular case, right? For this particular question, our slope is equal to 2. So we know that our rise over our run is equal to 2. But we could also write 2 as a fraction as 2 over 1. Agreed? From when we were doing fractions and decimals, you can turn a whole number into a fraction by simply writing a denominator of 1. So what this is telling us, we get two pieces of information from this. If our rise over our run is equal to 2 over 1, that rhymed unintentionally, then what this tells us is we can just sort of match the two numerators together and match the two denominators together and say that the rise is equal to 2 and the run is equal to 1. And what does that mean when we're trying to graph it? If we look at that fraction, so I'm going to just rewrite the fraction the way I had it before because you can't really see it anymore. Rise over run in this case is equal to 2 over 1. So we have something like this that we end up getting after we found the slope. And so this tells us that the rise is equal to 2 and the run is equal to 1. So what that means is if you started at this point and you don't have any of the other points on the graph, you haven't drawn the line, you don't have any of the other points, you're trying to find another point so that you can graph the line. What this is telling you is that if you want to follow a slope of 2, if you want your line to have a slope of 2, you need to go up 2 steps for every 1 step to the right. Right? Remember, the rise is moving up and the run is moving across. So you have to go 2 units up for every 1 unit that you move to the right. So from here, you have to go up 2. So that's going to take us up here, up here. So that's 2 units up is right to there. And then move 1 unit to the right. So that's going to take us right over here. So from here, we basically, I'm going to get rid of the -1 and the 0 just so I can sort of draw in a little thing. So our rise was moving 2 units up, and then our run was moving 1 unit over to the right. So we moved 2 units up, and then we moved 1 unit over. The reason we moved 2 up and 1 over came from this equation up here where we were talking about our slope being equal to 2 over 1. It's a little bit of a roundabout way to sort of get to that next point, but the advantage is once you master this shortcut, you can use that to create any line that you want. So you use your y-intercept to just plonk down your first point, and then you can use this equation over here for the slope to plot your next point. And you actually don't need any more than that in order to graph the line. Without having like a grid or graph paper or something, I'm plotting a bunch more points so I can try to connect the dots. But if you plot just 2 points and then you lay a ruler on your page, you should be able to just draw the line with only those 2 points. So your shortcut is you find the slope and the y-intercept, you drop a point where you see the same value for the y-intercept on the y-axis, you use slope is equal to rise over run to get from your starting point to your next point, and then you just drop a ruler and draw a line. All right, so it's a little bit of a confusing shortcut in a couple ways. It's maybe a different way of thinking that we're introducing with all of this graphing stuff and different ways to go about graphing stuff. I'm just like, if you take a step back and look at the board, what is going on? There's so much going on this board right now. So I promise it'll clean itself up. In the next lesson, what we're going to do, actually I can show you the paper that I have for it right now. What I was going to do is I was going to show you a graph of y equals 2x minus 2, which is the one we just did, up against a graph of y equals 2x, and a graph of y equals x minus 2. So you can catch a glimpse of this right now. Hopefully you can see it quite clearly. It looks fine in the camera from where I'm sitting, but hopefully you can see this reasonably clearly. I'm not expecting you to copy this down right now, but this is just to give you a rough idea of what next class is going to look like. If you want to try it yourself as a bit of an exercise, then this would save you some time next class, is try to graph. I'll just write the 3 equations up here so that you have them clearly, and you can copy them down. Try to graph y equals 2x minus 2, y equals 2x, and y equals x minus 2. I think that'll really highlight, that's a terrible x. I think that'll really highlight just how the slope and the y-intercept affect the way the line looks. But I'm thinking that next class what we're going to do is we'll regraph y equals 2x minus 2, or we'll do something that's slightly different from it. So we might do like 3x minus 2 or 2x minus 3 or something like that. And then we'll graph the same thing but without the intercept, and we'll graph the same thing but without the slope, so with a slope of just 1. And that'll, I think, sort of cement all of this stuff that we've been talking about in the last few classes. It'll cement all of that together. So yeah, hopefully this made sense. I am now going to run to campus to write up a lab report, which is so much less fun than talking about linear functions. So I'm a little jealous that this is the math you guys get to do while I have to do a whole bunch of other math. Yeah, if you guys have any questions whatsoever, please do not hesitate to reach out to me, because I know this is some pretty new stuff, and for those of you that were amongst the youngest in the class last year, this is still probably a year, or probably about a year above your grade level. And if there's anybody younger than that, then this is 2 years above your grade level, at least according to the education system I went through. So don't feel bad if any of this stuff is confusing. Send me an email or leave a comment or something if any of this is confusing and you want like an extra video. But yeah, otherwise I will see you guys in the next video. Have a good one.